Okay, this video is just going to go through 8.1, 8.2, 8.3, 8.4, and 8.5 homeworks. So I want you to open up your iPad, or actually get a piece of paper out and kind of go through these problems as we go and make sure that they are put in to your Schoology assignments homework section. Okay, 8.1 mystery bags. Okay. Lynn is interested in how many of her classmates watch her favorite TV show, so she starts asking around at lunch, and she gets the following responses. Yes, 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 no, 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 yes, no, no, no. So she asks one more person, wait, hold on a second. If she asks one more person randomly in the cafeteria, do you think they will say yes or no? So what do you think? Well, it looks like most of them, I got yes, 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 yes. Only 4 of them said yes, and the rest said no. So the answer here will be, do you think they will say yes? No, I don't think they will, because most of the people said no. Okay, so the next part says, based on the table above, what is the probability that the students will say yes? Write your answer as a fraction in simplest form. Oh, so I did this part wrong. This shouldn't say no there. Let me cross this out. That shouldn't say no. I have to put that as a fraction. So the fraction would be 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. 4 out of 14, but I have to simplify that fraction. So if I divide both of these by 2, divide by 2, divide by 2, that will be 2/7. And that is the simplified fraction there of the students that will say yes. Okay, so let's go to this one. Do you think, oh, let me go back here. An engineer tests the strength of a new material by seeing how much weight it could hold before breaking. Previous tests have held these weights in pounds. So I noticed that this has 1,000, over 1,000, over 1,000, over 1,000, not over 1,000, over 1,000, over 1,000. Do you think that this material will be able to hold more than 1,000 pounds in the next test? Select yes or no. Well, most of them are over 1,000 except for this one right here. So I'm going to say yes. I think this material will be able to hold over or more than 1,000 pounds. Okay, so a company tests 2 products to make sure they last for more than a year. Product 1 had 950 out of 1,000 test items last for more than a year, and product 2 had 150 out of 200 last for more for a year. If you had to choose one of these 2 products to use for more than a year, which one is more likely to last, product 1 or product 2? So what you have to do is product 1 had 950 out of 1,000 last more than a year, and this one had 150 out of 200. So 950 out of 1,000 and 150 out of 200. So all I have to do is divide those to see and figure out my percent. So I'm going to divide these down, get the decimal, multiply it by 100 to get a percent. So 950 divided by 1,000 is 0.95 times that by 100. That's going to be 95%. And 150 divided by 200 is going to be 75.75, which times that by 100 will be 75%. So if I had to choose one of these to use, which is more likely to last, well, that would be product 1. Okay, so a company tests two, I'm doing this fast and it's hard to see. A company tests 2 new products to make sure they last for more than a year. Product 1 had 950, same question. So find the probability, type as a percent. The probability that product 2 will last more than a year. Oh, I already did product 2 right there. So that would be, that would be 75%. I already did all that work, so that's done. All right, so yeah, that one's done. Okay, 8.2, chance experiments. It says the likelihood that Hans makes a free throw in basketball is 60%, and the likelihood that he makes a 3-point shot is 0.345 decimal. Which event is most likely to happen, or more likely, Hans making a free throw or making a 3-point shot? Okay, so you have to look at this information. I have 60% right there. This is a decimal, 0.35. So to turn that into a percent, I just multiply that by 100. And that right there would be 34. Oops, sorry, that's sloppy. This will be 34.5%. So which is more likely? Making a free throw, which was 60%, or a 3-point shot, which was 34%, it's more likely that he will make a free throw. So right here would be free throw. I like to call them free shots because I'm not just throwing the basketball, I'm shooting it, so it's a free shot, but most people call it free throws. All right, anyway, the likelihood that Hans will make a free throw is 60%. The likelihood he makes a 3-point shot is that. What's the probability of him making a 3-point shot as a percentage? Well, I already did that right there. So on this line right here, I will write 34.5%. Okay, so different events have the following likelihoods. Sort them from least to greatest. All right, so then I'm going to put them on the line. So 60% is 60%. That one's done. 8 out of 10, if I did the work there, that would be 8 out of 10. Divide that would give me 0.8. Times that by 100 to get a percent would be 80%. So this is 80%. If I turn this decimal into a percent, I just multiply it by 100. That will give me 37%. Okay. This one is already a percent. So to turn this fraction into percent, I do 5 divided by 6, which is 0.83. Repeat. Times that by 100. So I have a 0.83 repeat. That would be 83 repeat percent. Okay, so now that I figured all the percents for them, I just put them in order. So what's my smallest? Well, that would be 20%. So 20% I would put there. The next one would be 37%, so I put that there. So you're just going to slide these. The next one would be 60%, so I put that there. 80% would go there, and 83% would go there. All right. There are 25 prime numbers between 1 and 100. There are 46 prime numbers between 1 and 200. 25 between 1 and 100. Which situation is more likely? that computer A produces a random number between 1 and 100, or computer B produces a random number between 1 and 200 that's prime. So 25 out of 100 are prime. So for computer A, I'm going to do my work down here. There's computer A and there's computer B. For computer A, if I look, 25 out of 100 are prime. And for computer B, 46 out of 200 are prime. Now's the easy part. Once I figure out that fraction, you get the easy part. You just divide. 25 divided by 100 is 0.25 times 100. Gives me 25%. And computer B, 46 divided by 200 is 0.23 times that by 100 would give me 23%. Okay, so is it more likely that computer A or computer B will choose a random number that's prime? Which one has a higher percent? Computer A. So I would go with computer A on this one. Okay, and then this one just tells you to figure out the percentages, which I already did that work. So for computer A, I would write 25%. In computer B, I would write 23%. All right, we did that work already. Computer A has okay, this page looks very confusing, but it's really two assignments on one that's the same as this. So we're just going to look at the one at the top. All right, 8.3. List the number of outcomes. Wait, let me do that again. List the number of outcomes for each experiment. Flipping a coin is how many outcomes? Well, what can you get, heads or tails? So there's just two possible outcomes. Selecting the random season of the year. Well, how many seasons are in a year? Well, there's fall, winter, spring, and summer. So there are 4. Select a random day of the week. How many days are there in a week? 7. So that's the first part. Okay, flipping a coin, you could have heads or tails. Selecting a random season of the year, you could have summer, fall, this would be winter, and spring. Selecting a random day of the week, Sunday, this would be Monday, Tuesday, Wednesday, Thursday. Whoa, we forgot Friday. Friday and Saturday. All right, that's that. Selecting a letter from the alphabet. How many different outcomes are in the sample space? Well, how many letters are in the alphabet? You should know that. 26. What's the probability the computer produces the first letter of your first name? Well, how many letters in the alphabet have your first letter of your first name? 1. My name's Piper, P. There's only 1 P. So it would be 1 out of 26. What's the probability of selecting a random month of the year and getting a J, getting a month that starts with the letter J? First, I need to fill this out. January, February, March, coming up. April, May, June, July, August, September, October, November, December. Okay. Which ones have a month that starts with the letter J? January, June, July. That's it. So, what is the probability of selecting a letter that starts with the letter J. That would be 3 out of 12. But I need to reduce that. I divide them both by 3. That would be 1/4. Okay. That's it for that one. This I already did. Okay. 8.4. A carnival game has 100 rubber ducks floating in a pool. The person playing the game takes out one duck and looks at it. If there's a red mark on the bottom, the person wins a small prize. If there's a blue mark on the bottom, the person wins a large prize. And many of the ducks do not have a mark. Okay, so after 50 people played the game, 5 of them won a small prize. And 1 of them won a large prize. Estimate the total number of ducks that have red marks. So 5 out of 100 ducks, I would just guess, for that one, and 1 out of 100. So estimate them. Okay, total number of red ducks, I'm just going to say 5. Total number of blue ducks, 1. So after 50 people played the game, 5 won a small, 1 won a large. Find the probability. So what's the probability of picking a duck, red duck? 5 out of 100. A blue duck is 1 out of 100. So now you just divide those. Divide those and turn them into a percent by multiplying by 100. So 5 divided by 100 is 0.5 times 100. That would be 5%. And 1 out of 100 is going to be 1%. About. Okay. Lynn wants to know if flipping a quarter really does have a probability of 1/2 of landing hands up. So she flips a quarter 10 times. Using theoretical probability, type the number of times it should land on heads. If it's half the time, well, how many times should it land on heads? Half of the time, a half of 10 would be 5 times. So after flipping the quarter 10 times, it landed up 3 times and tails up 7 times. Has she proven the probability of 1/2? Type yes or no. No, because it only landed on heads 3 times, not half the time. So type the experimental probability of a coin landing on heads. That would be 3 out of 10. And turn it into a fraction. That is the fraction. So that would go right there. Okay. All right, so let's go to number 4. So a spinner was spun 40 times for a game. Here's a graph showing the fraction of games that are wins under some conditions. And do you notice that it starts up here and it gets a little jaggedy, and then look at it, it starts to even out. Kind of gets steady. It probably will stay steady there. Okay, so estimate the probability of a spin winning this game based on this graph. Hint, look where most of the dots are. So what they're saying is that most of the dots are within that range there. So if we follow this range over here, it's actually between 0.6 and 0.7. It's in the middle. So I would just go ahead and say 0.6 5, because if you look up here, it's between 0.6 and 0.7. So in between, if this was like 60 and this was 70, this would be 65 right in the middle. So 0.65. All right, and the last question here is rolling a standard number cube and getting an even number. The probability is what? Is a fraction. Well, 3 out of 6 are even, because if you think of it, 1, 2, 3, 4, 5, 6. There's your number cube. And even numbers, 2, 4, and 6. So that would be 3, 1, 2, 3 out of a total of 6. Okay? So to write 3, 6 as a fraction and to reduce it, 3, 6, I would divide those by 3, divide by 3, 1/2. So 1/2 would go here. What's the probability of flipping a coin and having it land heads up? Okay, well, a coin has a heads and a tails, and only one of them is heads, so 1 out of 2 total, so that also would be 1/2. Okay, here we go, 8.5. We're just estimating. This is kind of hard to see, and I apologize for that, but we're going to kind of go through this quickly anyway. All right, so Andre, oh, I can't see that. Let me try yellow. Andre picks a block out of a bag 60 times and then puts the block back into the bag. This is called replacement. He notes that 43 of them are green. What should he estimate for the probability of picking a green block from the bag? Well, when you estimate, he had 60 times, 60 chances, and 43 were green. So basically 43 out of 60. But let's estimate that. So this is about, what's an easy number to work with? 40 out of 60. And then I could just get rid of those zeros. That's 4 out of 6. And then I could reduce that by dividing it by 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. So the estimated fraction would be 2/3. Okay, so Mai looks in the bag and sees that there are only 6 blocks in the bag. What should Andre change his estimate to based on the information? So 2/3 of 6. So let's think about that. There's 6 in the bag. Whoops. So there's a 1, a 2, a 3, a 4, a 5, and a 6. Oh, I'm gonna take that out. There's 6 blocks in the bag. And how many of them? 1/2 of them, no, 2/3 of them are green. So 1, 2, 2 of the thirds. If I broke this up into thirds, 2/3 of them are green. So that would be 4 out of 6. So again, which is 2/3, I just write this 2/3. Okay. A person suspects a standard number cube is not so standard. He rolls it 60 times and it lands on a 6 23 times. Another person rolls the cube 60 times and it lands on a 6 25 times. A third person rolls it 60 times and it lands on 21 times. Based on these results, what's the probability of rolling a 6 using this number cube as an estimate? Okay, so I'm going to write down here. The first guy said 23 out of 60. The second guy said, another person said 25 out of 60. And the third person said 21 out of 60. So about how many times? I'd say it's between 20 and 25. So let's just go ahead and say 20, about 20. 20 out of 60, which is 2/6, which is 1/3. So about 1/3 of the time, it would be 6. If this is a standard number cube, use theoretical. How many times should it land on a 6? Well, it really should be 1 out of 6, because the probability of rolling a 6 is, wait. Sorry. So this should be, it should land on 6 about 1 time, because the probability of rolling a 6 is 1 out of 6. Okay, so hey, they were probably right. That seems a little suspicious. Okay, so a textbook has 408 pages numbered starting with 1. You flip through a landing page, and it's equally likely to stop on any of the pages. Okay, so what's the sample space? Well, sample space is numbers 1 through 408. Make that a little bit neater. And what's the probability you turn to 45? 1 out of 408. It's a very small chance. I mean, think about it. If I was I would actually bet money on that and say you're not going to pick that page. What's the probability that you turn to an even number page? Well, how many of these out of 408? If I divide that by 2, because they're even, divide it in half. Half of those pages are even. So 408 divided by 2 would be 204. So what are the chances? What's the probability you turn to an even page? 204 out of 408. And if I reduce that fraction, it would give me 1/2. 1/2 of them are even. What's the probability if you turn to page 100 or less? Well, how many are 100 or less out of that? Well, so I would just do 100 divided by 408. That'd be 0.24 times 100 to give me a percent. So it's about 24%. All right. And that is it for all this homework. I know I went fast, but hopefully that helped you a little bit. We've been reviewing this all week, so I'm just starting to get the hang of these probabilities.